Welcome to Google Cloud Next 2021. In today's talk, secure and reliable continuous delivery to Google Kubernetes Engine. In today's talk, we're going to talk through some of the challenges of continuous delivering to GKE. We'll discuss the principles that can be applied to address those challenges. We'll be introducing Google Cloud Deploy. And finally, we'll show a demo. My name is Bogdan, and I'm a product manager with Google Cloud, and I'm joined today by Bryan who's an engineering manager with Google Cloud. So let's start off by talking about challenges. Over the past 18 months, we've had the opportunity to speak with numerous Google Cloud customers about the continuous delivery challenges they face with GKE. And from those conversations, three themes emerged. The first theme is cost of ownership. Defining robust delivery pipelines, patching, tooling, and scaling an organizational continuous delivery capability can be both difficult and complex. And even when an organizational continuous delivery capability has been established, knowing what to measure and how to optimize those measurements for success is often unclear. But in all situations, continuous delivery investment intensity can detract from core business focus. So the second theme we observed was around security and audit. Controlling releases as they make their way out to a production environment, approving releases for production, as well as delivery pipeline access control and audit were repeated as fundamentally necessary to modern software delivery. And the final theme was integrations. Continuous delivery capability exists within software delivery ecosystems. And because of that, systems integrations, such as with continuous integration, connecting complex workflows such as multi-step, multi-party approvals, and advanced networking requirements demand continuous delivery tooling flexibility as well as modularity. And these three themes are best summed up by a recent customer quote. And that quote went something like this: "We cannot afford to be innovating in continuous delivery. We want an opinionated product that provides best practices out of the box." And while this quote is associated with one customer, the reality is it could be assigned to any number of customer conversations that we've had. Or now that we've talked about the challenges, I'd like to talk through some of the principles that can be applied to addressing these challenges. So there are four. The first principle is easy. Make it easy to define robust delivery pipelines, to onboard delivery pipelines, to scale them, and to apply best practices as part of their setup. And we believe the best way to do this is through a managed opinionated service, and Bryan's going to be talking more about that later. The second principle is control. Continuous delivery tooling must facilitate manual and automated release control as it makes its way out to a production environment. So that includes activities like promotion, rollback, as well as approvals. The third principle is security. And what that means is platform administrators must have the ability to restrict delivery pipeline definition and activities. They need to be able to control who is doing what, where, and when. And when an audit is needed, that should be handily available too. And the final principle is about providing insights. So a continuous delivery capability must provide insights, both collectively as well as individually, for delivery pipeline progressions, activities, and opportunities to further optimize delivery stability as well as release velocity. So again, the four principles are: make it easy. So make it easy to onboard, make it easy to scale, and make it easy to maintain continuous delivery tooling using best practices. The second is provide control. Releases should be controllable as they make their way out to a production environment. The third principle is security. Control who can do what, where, and when with audit. And finally, provide insights to further optimize your continuous delivery practices. So now that I've talked through these principles, I'd like to hand it over to Bryan, who's going to talk to how Google Cloud applies these principles. Bryan?
Thanks, Sander. Continuous delivery capabilities frequently exist within a software development lifecycle ecosystem. This implies flexibility and modularity, as Sander noted, as a delivery tooling requirement. For GCP customers, connecting Google and third-party tooling that intersects with your delivery processes is a necessity, particularly when you already have continuous integration, approval workflows, and associated test automation. We have found that GCP Kubernetes customers typically mature in their usage of GKE over time. Starting out, customers may have a single config that targets a single cluster, but this usually grows into multi-config, multi-cluster usage. From there, teams often find that application configuration should be standardized and source code controlled, allowing them to templatize configuration changes. Finally, advanced customers find tools such as kept and customized to be extremely useful in allowing them to make increasingly sophisticated and automated configuration changes across environments. Most software delivery pipelines can be thought of as a three-step process: define, manage, and deliver. Because usage of GKE is a journey, we advocate using scaffold for the local development loop. From there, scaffold profiles, in combination with a managed continuous delivery service, can be used to define delivery pipelines and orchestrate releases. Finally, that service can actuate the release to GKE target clusters. Up until this point, we've discussed the challenges, principles, and application of those principles for continuous delivery into GKE. Now I'd like to step through the key features of our recent public preview launch of Google Cloud Deploy, GCP's continuous delivery service for Google Kubernetes Engine. We have engineered Google Cloud Deploy to be a scalable managed service that enables continuous delivery to GKE. Cloud Deploy relies on a config as code model with declarative manifests for configuring the delivery pipelines. In addition, it performs GKE manifest rendering and deployment on your behalf. Cloud Deploy additionally supports a number of security features, including a discrete IAM model, direct integration to GCP Cloud audit logs, manual approvals as part of a deployment process flow, and even execution on Cloud Build private pools for customers that desire security and control over their environments. Finally, Cloud Deploy has integration points to enable both Google and third-party delivery-related tooling and process integrations. I'd like to briefly walk you through the experience before I go into our demo. In this first slide, you can see that Google Cloud Deploy organizes CD workflows around pipelines, which can be monitored and measured using the GCP Cloud Console, as well as our gcloud command line interface and API. Next, in the delivery pipeline details view, a pipeline's rollouts can be controlled through promotions and approvals, which are again available via the Cloud Console UI and the gcloud CLI. You'll also note a delivery pipeline's release history is accessible for similar review and taking action. Users with appropriate permissions can then proceed with a release promotion to evaluate configuration changes that are included with the release to be deployed. The Cloud Console user interface supports direct visual differentials to aid in the release progression decision-making process. I'd like to now demonstrate the use of Google Cloud Deploy to deploy an application to a series of GKE target clusters. In this demo, I will step through the process of creating a GCP Cloud Deploy release, deploying to staging, then approving a production rollout.
Today, I'm going to demo the new Cloud Deploy service from Google. We'll start with a GitHub repo that contains two applications that will build two containers. That application is in this example directory, and you'll see there's a container called Leroy App and a second container called Leroy Web. Both containers include their own Kubernetes deployment manifest, as well as a scaffold config that defines how those containers will be built and deployed. You can see here that we're planning to use the standard kubectl deployer to deploy to GKE clusters. If I take a look at GKE in my Cloud Console, you can see that I've already pre-created 3 clusters: a test, staging, and prod. So those are already ready and waiting for me. So the first step I want to do is to go into Cloud Shell. I've already pulled the repo down, so I want to do a scaffold build and upload those containers to Artifact Registry. All right, we can see the container build has finished. They have been uploaded. I'm going to go check out my Artifact Registry just to verify. Yep, we can see now, just now, two containers have been uploaded, Leroy app and Leroy web. So for my next step, I want to actually now set up my cloud deploy pipeline. My containers are built, they're ready. So let's take a look at what that looks like. Within my repo, you can see I have a declarative manifest for my pipeline. And it looks just like this, and it's very simple. I give it a name, which I've called it web app with a description. And then it really just defines three stages: test, staging, and prod. The order in which these are defined in is basically the directional flow that the pipeline will promote through. So let me go into my Cloud Shell, and I'm going to apply that manifest to Cloud Deploy. All right, you can see it's now been applied. I can go check out my Cloud Deploy user interface. I'm going to do a refresh here. All right, now we have a web pipeline, and it's as we mentioned, it's planning to promote from test to staging to prod. Those are actually resources as well that need to be created, and you can see I have those defined declaratively as well. I have a target test, target staging, and target prod. I've defined those in separate manifests, so I'm going to run those in now. That will create each of these targets in Cloud Deploy one at a time. All of these could have been added to a single manifest. I just opted not to. All right, so I've created the test target, the staging target, and the production target. At this point, I could do one of two things. The first step I'll take is just to manually create a release in Cloud Deploy. So I'm going to go ahead and create our first release, and we're going to call it Web App 001. And you can see now that we've created the release, and it's started a rollout to the first stage in our pipeline, which we call test. If I take a look at that, you can see the rollout has been queued. It's starting, and this is what the user interface looks like. We show that there's a test, a staging, and a prod. Rollout is queued. If you notice here, between staging and prod, it says 0 pending, and what that's referring to is 0 approvals. And it knows that because if we take a look at our prod manifest, we configured it to require approvals. So we'll talk about approvals in a little bit, but effectively, Cloud Deploy is aware and it's expecting an approval before it allows that promotion to that final target. While this pipeline is queued, we're going to go in and I'll show you as well that I've created a cloud build trigger that will automatically look for changes. And this is for those that are familiar with Cloud Build. This is looking at my Git repo. And anytime a change happens to that repo, a commit is made, it's going to build a new container, upload it to Artifact Registry. And then you can see here the second step is it's going to then create a new release. So we can test that out. I will go into my Visual Studio Code. I have a sample app here. Let's just call it Cloud Next 2121. We're going to update the comment here, apply the change, updated comment. We can see that trigger is running now. And what that trigger is going to do, it's going to update the containers in the Artifact Registry. And then when complete, it's going to kick off a brand new release in Cloud Deploy. Okay, our trigger has successfully run, which should mean that a Cloud Deploy release has been kicked off, and we see that it has. The test has been deployed, and now let's say we want to do a promotion. So we're going to go ahead, using the user interface, and force a promotion to kick off a promotion to the staging target. Okay, our promotion to staging was successful. So now we really have just one step left. That's to promote to production. But if you recall, production also does require a manual approval. So we're going to kick off the promotion. And you can see now we have one pending review. I'll click the review option. I'll go in there and I can see that, oh, look, I have a rollout that does need an approval. I do have the appropriate permissions, so I can go in there and review that. At this point, I'm ready to approve it. I know what changed. I can see the differences. And so I'm going to approve. I'm going to go back to my pipeline. Our promotion to prod was successful. And you can see now we have successfully promoted an automated release through test, staging, and production. This release was built off a GitHub trigger using Cloud Build. And this really showcases the end-to-end CI/CD pipeline using both Cloud Build and Cloud Deploy.
To learn more about Google Cloud Deploy, visit us at cloud.google.com/deploy. Now back to you, Sander.
I'd like to thank you, Bryan, for presenting this talk with me today, as well as all of you for attending Google Cloud Next 2021.